Hello guys, welcome to today's class where we'll be looking at another example on the remainder theorem. So in this example we have a polynomial f of x equals to x cubed plus qx squared plus 11x minus 2 when divided by x minus 1 gives a remainder of 3. Now Roman figure 1, find the value of q. Roman figure 2, what will be the remainder when f of x is divided by x plus 3. Now, in this case, you are given a polynomial which has an unknown value in it. So it has an unknown value, a q, in its setup. So we are asked to find the value of that particular unknown, that q, if when it's divided by x minus 1, it gives a remainder of 3. So what do we do here? Since we don't need to use our division method again, we already understand our remainder theorem very well. We know it explicitly, so we know we can easily use this here to get this. So we know when you divide, so the factor here, the divisor here. So first of all, let's bring out our function. We have x cubed plus qx squared plus 11x minus 2. So having this, the same so now the divisor that we're using in this case is x minus 1, giving a remainder of 3. So we are asked to find the value of q. So we are looking for q. So in this case, what do? The first thing we do is, from remainder theorem, I know that when I equate my divisor to 0, whatever value I now get of my x here can be substituted into the polynomial f of x, where I have 1 cubed plus q times 1 squared plus 11 times 1 minus 2, which will now give me the remainder. So in this case, I know this will be 1 plus q plus 11 minus 2, and I know the remainder already. The remainder here is 3, so I can easily get my q now. So using this analogy, I can say this is q plus 1 plus 11 is 12. 12 minus 2 is 10. So this q plus 10 equals to 3. It means q 3 minus 10. It means my q here is minus 7. Since I've gotten my q, then I've found my Roman figure 1. So I can bring this as Roman figure 1. Settled. For my Roman figure 2, I am told to find the remainder that will be gotten when that same function, that same polynomial, is divided by divisor x plus 3. So first of all, since I have gotten the value of q now, the first thing I will do here is to represent that q in the polynomial as minus 7. So I'll say, now, I'll just say, since q equals to minus 7, then f of x will now be x cubed minus 7x squared plus 11x minus 2. So this will now be my new function. Then I can go to my Roman figure 2. For my Roman figure 2, I am told to find the remainder when f of x will be divided by x plus 3. So for Roman figure 2, see, when the divisor is x plus 3, when the divisor is x plus 3, what is the remainder? So in this case, you are given the divisor. We already have the polynomial, the full polynomial, and then we are asked to what? Find the remainder. So from remainder's theorem, using remainder's theorem, I know that my x plus 3 equals to 0. My x will be equals to minus 3, and then I can say that minus 3 cubed minus 7 into minus 3 square plus 11 into minus 3 minus 2 will be equal to the remainder. So I know my remainder in this case will be minus 3 all cubed, that's minus 27, minus 7 into bracket, minus 3 all squared, that's 9, plus 11 and minus 3 minus 33, then minus 2. This gives me minus 27, minus 7 times 9, that's minus 63, minus 33, minus 2. Moving forward, I know, simplifying this further, I know minus 27 minus 63, that's minus 90, minus 35, giving me minus 1, 2, 5. So this will be the remainder here when the divisor is this. So therefore I can say when f of x is divided by x plus 3, the remainder gotten is minus 1, 2, 5. So that is our final answer here, and then we'll take one more question on remainder theorem before we call it a day on remainder, and then take random questions on polynomials. So see you next class, and then do well to work on your abilities on the remainder and the factor theorem, as they are both interconnected and can be used simultaneously.